Right, so welcome to this lecture on practice problems, mainly in Z transform, and we will see if we have time for Laplace also. Otherwise, we'll solve a couple of problems in Z transform. I think we will try to do it like this, that I'll give you a problem, you will try it, yes, and I will help you out. Okay, so let's see. You remember now, by now you have revised or looked at what is Z transform, right? So when you are going to solve problems for Z transform, you have to recall or collect all the important points related to Z transform on maybe half a sheet, you know. ज़्यादा नहीं लगता, it doesn't take a lot for one whole topic to be covered. Okay, so always make summary notes related to the topic you are going to practice for. Yes, firstly, what you do, make summary notes. Yeah, when you are taking lectures or reading from the material, take paper and pencil, take some notes, and then summarize those notes. Okay, take out the key elements. Your book from Lati, I think, is 1,000 pages. Okay, अगर आप समझते हैं कि वो सारा कुछ आपने करना है, that's not how it is. You always have to, usually one whole page, the summary from that should often be just maybe one line, that's it. Okay, or even one formula, that's it. So when you are studying, always study in a way that you have paper and pencil in hand. Okay, take notes. If you read one paragraph or if you see one of my slides, yes, look at that, and then on the side or on your sheet, summarize that in one small line. If you're writing in long sentences, big paragraphs, that means you didn't get it yet. Okay, and if you miss to summarize some important part, then you didn't get it again. Okay, so this is a test for yourself also. Now, once you have collected the summary points from the lectures on Z transform, put them on one sheet or maximum 2 sheets. Okay, just the summary points. Okay, this is Z transform summary points. Okay, very important points, that's all. Then what you do is you take this sheet of summary points and then you find practice problems. Where do you find practice problems? In the assignment, in the solve problems in the book, right? When we say practice, that means often you should have some solutions. So it's good to look at problems that are solved in the book. You are given quizzes, right? Made those things, so you can find several different practice problems. Then what you do is look at the problem. When you see the problem, what's the first thoughts that should be coming to your mind? What do you need to identify in the problem? Right? Firstly, identify, okay, what is this problem talking about? Right? So if it's a quiz on Z transform, you already know. But in the mid and final, what happens? You don't know, right? Problems can be in a different order. So always first identify what this problem is about. But of course, it's going to be one of the topics that we have covered in the course, right? कोई नई research तो नहीं कराएंगे हम आपसे, ठीक? So let's say you look at it and you realize, okay, this problem is about the Z transform, right? Then what you need to do when you're practicing, you need to refer to your summary points and see, okay, which of the points or which points do I know about Z transform? Just refresh in your mind quickly, and then look at the problem and see, okay, which of these would apply here? What is the problem asking for? Right? What is given? What's it asking for? And which of these will apply to this problem? Yeah? Bring those out and then try to use them on that problem. Now, when you are practicing, one mistake students make often is that they quickly look at the solution. Yeah. So don't do that. Always try at least 3 times before. You can look at the answer to see if you reach the right answer, but don't look at the solution. Why is that? You know why that is? See, if you see Messi scoring a goal, You may think, yeah, football is easy, anybody can go and do that, right? Why is that? He makes it look easy, right? Because he's on the top of his game. So when you see a solution, whoever wrote that solution may have tried a couple of times and then written or printed the best version, right? So you may look at it and say, oh yeah, yeah, it makes sense, it's so easy. Okay, it's only when you try by yourself that you realize, okay, I didn't get the right answer. Where was I wrong? Did I pick the wrong summary point, wrong formula? Or maybe I picked the right formula, but then its implementation, mathematical steps had mistakes. So that means, okay, conceptually I was right, but then I need to focus more on the steps when I do them or revise them, right? So by looking at solution, you always kind of deprive yourself of that learning opportunity. And I've said this in the start of the course also. Many of you say that I knew this exam, but or this question, but I made a blunder. So I think blunders are just lack of practice. Okay, you're given the timed exam. You have 3 hours in the final, 1 hour in the mid. You don't have time for blunders. Why we do that? We want to know how many of you or which of you have been really practicing to get comfortable with these topics. That's the idea. Yes? वरना हम आपको 6 दिन दे दें करके ले आए या वहीं बैठे रहे करते रहे रोज आए करे कर eventually कुछ ना कुछ आप कर लेंगे, right? But is that good enough? You hire someone to make food for you. Yeah, that person is experimenting in the kitchen for 10 hours. You just भूख खत्म हो गया, सब कुछ तबाह हो गया, right? It's not like that. So when you are a practitioner of a field, when going to use something in your field, you should be comfortable with it. That's why we give you timed exams, right? ताकि आप क्या करेंगे? If you have practiced sufficiently, you will make fewer blunders, very few. Okay? So corresponding to each summary point, you should try to solve 2 or 3 problems. Okay? So अगर Z transform के, let's say you ended up with 8 summary points, then try to solve 2 to 3 problems with related to each of those. Okay? Then you will get really comfortable with it, and then you will not make the blunders that you call blunders. Okay? अब इसमें कोई memorization नहीं है as such. There is no memorization here. We give you the formulas, most of them, right? It's more of an understanding of helping your mind organize the information you have, right? किसी point तक तो memory होती है ना. Of course, you have to know what is a Z transform, क्यों use होता है, right? That a difference equation can be solved with the help of a Z transform. Now ये तो memory है ना, but conceptual memory. It's not रट्टा नहीं है उस तरह का, right? So then the last thing is, when you are solving problems, you see example problems, you solve them, and you find that there was some trick used in the problem. Okay, होता है कभी कभार हम use करते हैं. I gave you one Z transform problem where you had to split Zn plus 1 something into Zn times Z, remember? Then it was solved easily. That was a trick. अब वो कहीं नहीं लिखा हुआ किताब में ऐसे, right? So sometimes there are tricks, but I can tell you an important tip about tricks. Okay, in a given field or course, they are often repeating. ऐसा नहीं होता है बहुत ही extreme किस्म के tricks हैं, ठीक है? They are often repeating. So what you do, if you're practicing and you see some tricks, some important ones, हर चीज नोट ना शुरू कर, फिर again you will end up writing another book of 1000 pages, right? Summary, most important things. Yeah, if you see a important trick showing up a couple of times, put that in your summary notes also under tips and tricks. Okay, then when you're practicing next time, revising next time, you will have this fresh in your memory, in your understanding. Okay, again, why are we doing this? To give structure to your understanding. और आप देखेंगे अक्सर लोग who are very good at जिसको हम quick thinking कहते हैं ना, why is Google able to answer your queries in like 0.0000? Why? क्या होता है? The internet is huge, right? कैसे देता है जवाब फौरन? क्या करता है? लेकिन एल्गोरिथम पे यू हैव एन एल्गोरिथम. आपने पूछा जी के टेल मी अबाउट, या डॉक्टर नवीद लिखा आपने, ठीक. इंटरनेट इज ह्यूज, राइट. कितनी फाइलें हैं, कीवर्ड्स हैं, सो मैनी साइट्स, राइट. हाउ डज गूगल इमीडिएटली आंसर यू? ओके, ये 15 जगहों पे इनका जिक्र आया है. क्या करता है गूगल? स्कैन करता है. You know, Google is all the time, it never sleeps, right? Thousands of computers around the world. What are they doing? Bots. They are scanning the internet all the time, collecting all the keywords, and then seeing where are these keywords repeated. For them, every word is a keyword, basically, right? So if the crawler sees Dr. Naveed at one point, it will put it, okay, Naveed Arbad, then it makes it one keyword, right? And wherever else it sees it, it links them. Okay, like, and then where it appears more often or in more searches, right, that it gives a rank to. But the important thing is, Google does not start thinking or searching when you give the search term. What has it done? It has already done that and organized the information. It has ranked the information. कौन से pages about Dr. Naveed are more commonly visited, so they have higher rank. Yes, so they should be in the results first. That's one thing. Secondly, it already has that information. उस पर सर्च शुरू करेगा. आप अपनी विंडोज पे अगर इंडेक्सिंग अब तो है, पहले नहीं होती थी. You couldn't even find something in your windows. आप देते हैं ना वर्ड, तो if you allow it to scan your documents, even your computer will take like 30-40 minutes to scan your own documents. Imagine scanning the documents of the whole world. Yes, of the whole internet. It's impossible. So what Google does is, all the time it's organizing this knowledge, right? And then when you ask it, so this is very similar to what many quick thinkers do. They are very good at organizing knowledge. Okay, अगर आपने एग्जाम में बैठ के ऑर्गेनाइज करनी है ना, तो फिर 3 घंटे तो एक ही सवाल होता है सही से, राइट? बाकी में ब्लंडर्स होते हैं. सो ऑर्गेनाइज योर नॉलेज. And of course, organizing doesn't mean कि अब अगर ये आपके summary points, you make summary points for Z transform, the book has 50 pages on Z transform, your summary pages are 20 pages. That's not good. You wrote another summary book, right? Should be very comprehensive, right? Extract the most important points. So the reason I'm telling you all this is, देखिए, we do a lot of discussion on concepts and theories, and we test some of those in your project, right, in your labs. But the exams and the quizzes are almost all based on what? Numerical problems. ऐसे ही है ना? We test your concepts inside that. Yeah. So you need to find a way to break this numerical problems code. How do you solve numerical problems? Many of you, unfortunately, you read through a book, I see you're highlighting, and then the whole book is highlighted. Yes, okay. क्या फायदा हुआ उसका? दोबारा से लाठी की किताब आपने लिख दी, हाईलाइट कर दी, सारी किताब ये है. You're not collecting the key information, right? Okay. Then those of you who do that are not practicing that information. Solution आप जल्दी से देख लेते हैं. देख के आपको लगता है कि it's very easy. Of course it is. It looks easy once it's done. बड़े बड़े दुनिया के theorem, once they are solved, they are very small, right? पर वहाँ तक पहुँचने में sometimes it took us hundreds of years. क्यों इतना सा था तो क्यों नहीं हो रहा था किसी से, right? कोई insight चाहिए थी कुछ. So help yourself by practicing this, and that's why we give you assignments and the solution to assignments, quizzes, solution to quizzes. ठीक है, आपने quiz के दिन ठीक नहीं किया, quiz solution तो आ गया ना, answer देखें उसका, सिर्फ खुद try करें घर जाके, right? Try a couple of times. नहीं हो रहा, then ask yourself, okay, what's missing in my summary notes? Yeah, जो why am I unable to do it? देखिए, ये अगर आप code crack कर लेते हैं, it involves learning, it involves making or giving your learning a structure. That, what does it entail? It results in quick thinking in those topics. That then leads to good grades. Yeah, but again, grades should not be the goal, but as I mentioned, since getting there involves all of this good structural knowledge concepts, तो अच्छी बात है, साथ grade भी आ रहे हैं तो क्या बुरा है, right? So try to plan like that. आपके अभी इसके बाद भी you have 3 more semesters, right? If you develop the right habit of breaking this code of solving numerical problems, I think you will do wonderfully well. And let's practice that here also. That was the general philosophy, not just Z transform, right? Everything you learn, okay, in life. Even jo social sciences, no formulas, no numerical problems, right? Even there, if you structuralize your knowledge, you are much better off. Okay, so let's go now into one of these topics. I'm not going to cover the full summary notes for you. You have to make your own. That's the thing about the summary notes, they have to be yours, okay, for you to for them to make sense to you. मेरे होंगे वो होता है फिर आप उसको याद करना शुरू कर दें, right? So we don't want that, right? What I'm going to do here is summarize what we know about the Z transform. Okay, we know a lot, but there are some points that we need to look at more carefully. Firstly, of course, the definition of Z transform, right? So क्या था Z transform की definition? XZ. There is a sequence xn. I want to take its Z transform. That is xn z minus n, right? We have done this in great detail. For unilateral, it's 0 to infinity, and for bilateral, it's minus infinity to infinity. Okay. In this course, mostly we will implement unilateral, 0 to infinity. Okay, but I'll skip that because it doesn't affect our formulas that we'll be using. Right. What else do we know? We know that Z transform has this important property that it converts convolution, let's say this thing, into multiplication, right? Important property. Then we know that if Yn has Z transform Yz, then what's the Z transform of Yn minus 1? If it is shifted by 1 unit in time, then you have Z minus 1, whatever it was originally, right? So if Yn had Z transform Yz, then Yn minus 1 will just be the same multiplied by Z inverse. What I often skip here is the initial condition. Okay, so the initial condition formula goes, how does it go? It is Z inverse and then there is Y minus 1, small y in time. Okay, and this is the initial condition. Okay, what else? Let's say the same rule keeps on applying. Okay, so I'll just show you the pattern. Z minus 2, yeah, Y Z. We normally write up to here. We skip the initial condition as being 0. But if they are not 0, what do you have? The pattern is very simple. Z drops in power, so it's Z minus 1. And then you get the first initial condition, Y at minus 1, plus then Z 0, meaning Z is gone, and Y minus 2. Now with the second order differential equation, to solve it, how many initial conditions do you need? Differential equation पढ़े हैं ना, हाँ, 2 चाहिए होती है. Same is with difference equation. Difference equations order is determined by the highest lag they have. इसमें highest lag अगर 2 है तो you need 2 initial conditions to solve it. Okay, unless you say initial conditions are assumed 0, then you are still giving initial conditions, but they are all 0, right? So this pattern repeats. Don't worry, I don't expect you to memorize this in a great detail. Okay, you should know this thing. Formulas aapko you will be given, but at least this thing, the very basic, that n minus k leads to z minus k y z, and then there's some initial condition thing. Yeah. Okay. What else? This is more about Z transform. Then we also did for inverse Z transform. Remember? Inverse Z. Yeah. So what was that all about? To get inverse Z transform, what was the first step? So you are given, now here you are given xn and you want to get xz. There you are given xz and you want to find xn. So what was the first step? Let's say the first step was apply partial fraction expansion to what? Xz divided by z. And I mentioned all that. I'm just now collecting the summary points. I'm not going to repeat the concept. We have discussed that. Yeah. So once you have applied PFT to that, you do multiply by z to remove this effect. And third, usually you will end up with several terms, because that's how partial fraction expansion works. And you use in general, this is the formula you end up using, which is z over z minus gamma is gamma n u n. Okay. In the exams, and also to see, this is quiz from last year, I have given important formulas. Yeah. But don't expect everything. Like, you should know delta n as Z transform unity. Yes. So कुछ तो basic तो आप पता चाहिए. And you can also deduce from this table, by the way. But anyway, so what did I just do? I collected some important summary points. Okay. Now, if you are not comfortable with partial fraction expansion, then your summary points should also have a few words or lines about how to do partial fraction expansion. Okay. For the purposes of this course, maybe in assignment you may have partial fraction expansion for repeated roots, but in exams I will not do that. Only distinct real roots, because that's not the purpose of this course, right? To get you stuck in partial fraction expansion, you do that in other courses. वहाँ आप repeated real roots भी देखते हैं, distinct real roots, complex roots, right? You see all those examples there. You may have it in the assignment, but then in the assignment you have the book with you, right? आप देख लें कैसे होना है. But in the exams I don't plan to do that. Yeah, only distinct real roots, because I just want to see that you grasp the main concept of the getting inverse Z using the partial fraction expansion, right? Not really teaching you again partial fraction expansion or testing you on that. You have been tested on that, hopefully. Right. So this is my sort of my main summary thing. Yeah. And now I try to solve one of the problems. Let's say in your assignment there is a problem so let's call it A. You are asked to find the Z transform of this thing. Okay. Now, as I said, when you look at a problem, what's the first thought that should come to your mind? Oh my God, ये तो मैंने पढ़ा नहीं है. Right. After that, it should be, what's this problem about? Today, since we are solving Z transform, it's very obvious, or लिखा ही हुआ है बल्कि, so nothing to dig in. But sometimes we don't mention what you are supposed to do. We just ask you, okay, is this system stable? Yeah. Then you okay. First, I'll take the Z, maybe I'll take HC, and then I'll check the poles. You know. So you have to know that. Right. So find Z transform of this thing. Yeah. Now from these, let's say these are the summary points. Okay, your summary points should be a bit more. I've just covered some here. कौन सा है यहाँ से? What will be your plan of action?
So Zn minus 4.
This one? Yeah. By basic definition, you can try. Okay. So करें try थोड़ी देर, 2-3 मिनट try करें, then I will see and help you out. You can use the unilateral Z transform, that is fine. So in the exams also you will have the tables with you. So here it's good if you try by basic definition, but there are more ways to do it. Okay, for example, let's say you have been given this, that un has Z transform Z over Z minus 1. Okay, ये भी आप यूज कर सकते हैं, or you can go by definition. Try either way. So there are multiple ways to attack this problem. Okay. If you are going to use the basic formula, then you should maybe simplify this thing to look at what this really is. UN क्या है? What is UN? Unit? Unit step, right? So in discrete time, yeah? So let's say I wanted to plot this first quickly. Okay, just to get an understanding of this function. So what is the first term? Un. Un is starts at n, which is 1, 1, 1, 1, and so on, isn't it? Okay. What about the second term?
Starts on 4.
Starts at
4.
So if this is 0, 1, 2, 3, 4. So it starts at n equals 4. Remember, what was this? Negative 1 shifted, delayed to the right. Yes. So this is shifted to the right, starts at 4, but because of the minus, what happens? Is it like 1, 1, 1, 1 additional ones here, or is it like this?
Why flipped?
Okay, it's flipped. Yeah, why? Because of the minus. Now from 4 onwards, what happens? Remember, the first term is going on. Yeah, but then from 4 onward, another term shows up, which is minus 1. So it starts doing what? Cancelling it out. So what happens? It's only these 3 terms. 0, 4 terms. 0, 1, 2, 3. And what are those terms at these are values are 1 1 1. Now if you understand this, then you look at, okay, xz is xn z minus n, n is 0 to infinity. In this case, where is n now? 0 to 3, right? And what's that value from 0 to 3? 1, right? So now if I write it out, I open the terms. So x0 z0, yeah, so that is gone, z minus 0, plus x1 z minus 1. I'm expanding this series, yeah, x2 z minus 2, x3 z minus 3. Now it goes further, but I know my function, this x becomes 0 after that, so I drop all of those. And what is x0? It's 1. What is x1? It's 1. What is x2? It's 1. What is x3? It's also 1. So this is the Z transform. Okay, of this function. Now you could have done it in other ways also. If you want to say, you know, आपको ज़रूरी नहीं है कि you do it exactly. I did a efficient way, okay? But let's say you didn't do that. Let's say you started with the definition. If you're looking at these kind of terms, always please try to expand it. Yeah. Let's say आपने ये ना किया होता, you still have access to this thing. Yes. Okay. Then you have try to always write a few terms and say, okay, I don't know where it goes, let me see. Yeah. Then ask yourself, okay, this is general, this applies to any xn. Now ask yourself, okay, what is x0? Even from here you can check. Yeah. x0 is u0 minus u minus 4. U minus 4 should be 0 by definition of u, and u0 is 1, so you put a 1 here, right? Then you ask yourself, okay, what is x1? Right? You get u1 and u0. u1 minus 4 meaning minus 3. So in negative this is 0, we know. So you again get a 1. You get up to 3, after 4 you will see it's all zeros and you realize the pattern and say, okay, so there's more than one ways to do it. Okay. You could also, I leave it as an exercise, you could also try to use this along with the delay operation that we know. Okay. So that's one thing. Okay, now let's try another one. Let's say you are given a sequence 1 4 8 2 and the arrow is here. किसी को याद है ये? Origin 0. Yeah, when n is 0, this represents n0. So I'm saying x0 is 1, x1 is 4 and so on. Yeah. इसका find करें. Find xz. Again, ask yourself always, what's this problem about? What is it that we know about it? What can we use? Again,
plus 4 z inverse.
So how are you doing it? Again by definition. Yes, because it seems the simplest thing to do. xz is summation xn z minus n, n is 0 to infinity. That means it is x0 plus x1 z minus 1 plus x2 z minus 2 plus x3 z minus 3 and so on. In our case, x0 is 1, x1 is 4, x2 is 8, x3 is 2, and even if you had written another term here, it's fine. You could just realize, okay, beyond this my x doesn't exist, it's zeros all, so you would stop here. That's your z transform of this sequence, right? Okay, let's make it a bit interesting, bit more interesting. Xn is 0.5 n un. Okay, find the Z transform. I'll let you try it. This is question 2 of your assignment. जो आपने कल submit करना है. And of course you have to give viva. So by now, do you have any thoughts about it, by the way? How will you attack this problem?
Yes. There's a
How?
unit function, sir.
Okay.
So z divided by z minus 0.5 raised to the power into unit step function.
हाँ? वो तो unit तो time में है ना? So your approach is to use this.
Yes.
That's fine. I didn't say how to do it. Okay, but of course you can reach this through the definition also. Okay, but since I didn't say that, ये है ना आपका. Yeah. So always ask yourself, what are the things I know, what is allowed. If I had said, okay, find this by definition of the Z transform, which is this thing, definition, then you cannot use formulas. Yeah, वैसे तो मैंने कुछ नहीं कहा ऐसा, right? But I'll show you, if you want to use definition, you can still get there. थोड़ा सा आपको time ज़्यादा लगेगा, but you will still get there. It may look a bit different in form. I'll do it very quickly. Again, by definition, xz is summation xn un. So let's say it's 0.5 n un z minus n. Why is that? I put xn here, yeah, and n is 0 to infinity. What is un in this range?
So what?
Un in this range is
1.
1, so it's irrelevant. Remove it. What's left?
0.5 is lower.
3 minus n, right? Okay. Is this, what does this remind you of? Let's say we write it as 0.5 3 minus 1 raised to n, right? N is 0 to infinity. So does it remind you of what? Symmetric series, right? And we know that summation, let's say an for n 0 to infinity is 1 over 1 minus a if, what's the condition? A is less than 1, right? Sometimes we write a r n and with that, but this is the simplified version of that. So based on this geometric series, by the way, if I give this in quiz or exam, I also mention geometric series in the formulas, not with the problem but somewhere in the formulas. So those of you who want to use it will know, okay, there is a formula for geometric series that I can use. Okay, then what is A in our case?
0.5.
0.5 Z inverse. So this thing should sum to what? 1 over 1 minus 0.5 z inverse, but under what condition? That 0.5 z inverse absolute should be less than 1. So this will give you region of convergence, but otherwise you have this solution. अब आपने जो solution निकाला था वो क्या था?
Sir, z divided by z minus 0.5.
5. But this looks a bit different.
Sir, वो ऊपर चला.
है ना? So you can still reach there. They are both same. Multiply and divide by z. You get z by z minus 0.5, which is this thing. So remember, even sometimes, even if you don't use the, let's say, the best or the shortest approach, the other one is not too far off. Okay. So it's up to you how you manage that. Okay, now let's do one problem from, let's say, difference equations. This was, what was this? Just getting the Z transform. If you remember some lectures ago, we solved 3 problems for Z transform. We did that in the class. वो भी आप ज़हन में रखें. Oh, sorry, ये तो रुक जाइएगा. That was using formulas and tables, formulas and properties. So write it again, summation xn z minus n, and this was xn convolved with hn. Okay. So let's say you are given a DT-LTI system, okay, and the system is yn minus 3 by 4 yn minus 1 plus 1 by 8 yn minus 2 equals xn. This is a problem you're given. You're told that this is a DT-LTI system where yn is the output, xn is the input. Okay, and you're asked to solve this difference equation. Solve using Z transform given that xn, the input, equals un, unit step, okay, and all initial conditions are 0. Okay, so you are told, okay, solve this one using Z transform. Okay, when we say solve this using Z transform, what do we mean? Or solve this difference equation, we mean find yn in terms of not yn, right? There is a lot of yn over here. It's solved iteratively. So we want to find a closed form solution to yn. कौन सा? All initial conditions are 0. G. How do we start? What do we know? We know now, of course, this is about Z transform, right? This is a Z transform of a difference equation, which is representing a DT-LTI system. क्या use करेंगे यहाँ से? Force. इस तरह के प्रॉब्लम में don't go to the definition, okay? Use properties and pairs. So you have this one, see? इससे आप करेंगे, हमने we have already done that when we developed. So try करें, write Z transform of this thing. Start करें, y z की फॉर्म में लिखना शुरू करें. This is question 1 of quiz 4 from last year. Okay, इस साल का नहीं है.
Initial condition 0 है sir.
1/8 को क्या हुआ?
So 1 by 8 x y minus c.
2 है 2.
Minus.
There is something called a mixed notation of n and z, but we don't cover in this course. Like there is n, there is n, there is z, then there is z transform. 2 है. कुछ हुई progress? So how are you attacking the problem? You take z transform on both sides. First term is y z. Yes. Then minus 3 by 4 z minus 1 y z. Then plus 1 by 8 z minus 1 minus 2 y z. Agreed? Yeah.
Yes.
Okay. So that's these things. Yeah. With initial condition set to 0, so it's y z minus 3 by 4 z inverse y z plus 1 by 8 z minus 2 y z equals x z. That leads to y z being equal to what? 1 over 1 minus 3 by 4 z minus 1 plus 1 by 8 z minus 2, right, times x z. अब क्या करेंगे? Is it done? We need to find yn, right? So we will have to do inverse z transform. But before that, we have to put all our cards on the table. So far we have only done this thing. What about xz? Quickly, what is xz?
So unit step function.
Unit step का मैंने आपको कहीं पे
Sir, वो ऊपर
दिया था, erase कर दिया. But often you can get from here also. Set gamma to 1 and you again get the formula of un, right, which is z over z minus 1. So for completing this, I write it z over z minus 1. Okay. Now what do I have to do to get yn? Remember, solving differential equation means finding the output, this thing yn. Yeah, how do you get it? So, and of course on the right hand side should not have another yn minus 1, then it's not really solved. So क्या था तरीका? Which part applies now?
Third.
So you have applied this thing. Now you want to go from yz to yn. What is that operation called? Inverse z transform. Right. Apply partial fraction expansion to xz over z, or in this case you have yz, so apply to yz over z. Yeah. So let's do that. First let's make yz over z. What's that? Yz over z. This z disappears, right? And you have 1 over 1 minus 3 by 4 z minus 1 plus 1 over 8 z minus 2 1 over z minus 1, right? अब क्या करते हैं partial fraction expansion में? What's the first step? Often make these as factors, right? Once you have factors in the denominator, from here on it's got nothing to do with this course, z transform or those things. It's all about partial fraction expansion now. So you have to know that. Yeah, यहाँ पे मैंने वो summary में बस लिख दिया. If you're not comfortable with those, you should have very quick summary points, half a paragraph mentioning the key points of partial fraction expansion. So कैसे बनाएंगे इसको? Multiply and divide by z square. Okay, first, so you get rid of the negative here. Yeah, so let's do that. We have this.
Then
कोई नहीं आप बस आ जाएगी. So you multiply and divide by you multiply and divide this thing by z square. So what do you get? Z square over 1 minus 3 by 4. What is it? Z, yeah, plus 1 over 8, and here you have z square. Sorry. Z square minus 3 by 4 plus 1 over 8. Yeah, this is what you get, times 1 over z minus 1. Okay. Can you do factorization of this? कुछ याद है कैसे होती है? So what do you do when you practice this thing then? You have to ask yourself, okay, I have to revise how to do factorization, right? कुछ चीज़ें आपको steps आने चाहिए. I will write the final factor form here. Its factors are 1 by 2 and 1 by 4. Okay, so this thing is actually z square over z minus 1 by 2 and z minus 1 by 4. Okay, this thing you do in early algebra and everywhere, right? Factorize it, and then you have 1 over z minus 1. This is now your yz over z in a form that can now be expanded. तो क्या होगी इसकी partial fraction expansion? How many roots? 3, right? Real, distinct. So it's the easiest case. You say, okay, c1 over z minus half plus c2 over z minus 1 by 4 plus c3 over z minus 1. ऐसे ही है, right? Okay. So what do you do with this? Cross multiply, or if you know, remember there were shortcuts in partial fraction expansion. To find C1, use the cover up rule. What's the cover up rule? If you want to find C1, cover the denominator of C1 in the original. Cover कर दें. क्या बचा? Whatever is left, put the root of this denominator there. So z equal half रख दें इसमें. Okay? z क्या आ जाएगा? ये कवर कर दें और z equal to half रखेंगे तो ये 1 by 4, यहाँ पे 1 by 2 minus 1 by 4 and whatever 1 minus 1 by 2, right? उसको आप solve कर लेंगे, एक नंबर आ जाएगा. If you, there is a quick check. If you cover up the wrong thing, क्या होगा? See, if you cover up this thing and then put z equal to half, तो वो infinity हो जाएगा. Half minus half. So you will realize, okay, I made a mistake. So if you want to find C1, cover up the denominator of C1 and put the root related to C1. That's all, right? इसकी root, इससे related root half है, yeah. That's a shortcut, by the way, for partial fraction expansion. But you can use, as you said, cross multiply, और उससे भी आप 1 by 1 कर सकते हैं. Anyway, you just cover this and put half here, एक number आ जाएगा. What to get? How do you get C2 then from here? क्या cover होगा?
Z minus.
This covered, and what value of z should you put? जिसको cover किया है उसी की root डालिए. तो इसकी root 1 by 4 है. Root आते हैं निकालिए.
Yes sir.
Z minus alpha को आप 0 रखते हैं और फिर जो भी बनता है वो value होती है. ऐसे ही है ना? So easily you can see it's 1 by 4. So 1 by 4 रखेंगे, C1, C2, C3 आ जाएंगे. Once you have all of them, I will just skip that part and I will write the roots here. So it is basically, where is it? 8 by 3 z minus 1. Okay, so this one 8 by 3. I'm just jumping to the final values that we get for each of these. Yeah. So 8 by 3. Actually, they have it In there they have C2, C3. The order is different, so I'll just follow what we have here. In that case, Z C1 for us is minus 2. Okay. Minus 2 by Z minus half plus for us it is 1 by 3, Z minus 1 by 4 plus 8 by 3 over Z minus 1. ये अब क्या आ गया? What is this? YZ over Z. Yeah, that's the first step you have done now. Apply partial fraction expansion to XZ over Z. What's the next thing? Multiply out by Z to remove this effect. Yeah. So if you multiply out by Z, that is not equal because now you're doing an operation. क्या हो जाएगा इधर? Minus 2Z, Z and Z. Third step, use this. Yes. Normally you end up using this formula. So what is this formula telling you now? Quickly, what is Yn? क्या आपका guess है जी? Educated guess. Inverse transform this using the formula table. Yeah, this usually you end up. So क्या होगा? Yn पहली term. What's the inverse of this? Yes, minus 2. Z over Z minus half का क्या है? From here
0.5
and half and un. That's inverse of this term, right? Plus 1 by 3, then Z over Z minus 1 by 4. What's the inverse?
0.25 raised to the power n.
Yeah, so 1 by 4 raised to n un. Fractions में decimals थोड़े से आप भी परेशान हो जाएंगे values में और mistake के chances होते हैं. So what's the last thing? 8 by 3 and 1 raised to n doesn't matter, un. Right? This is your answer. Okay. This is yn. Now you can, अगर आपको y0 निकालना हो तो क्या वैल्यू है? Just put that here. n को 0 रख दें, u0 1 हो जाएगा और this is 1 1 1. Basically it's minus 2 plus 1 by 3 plus 8 by 3. y 1 y. Now you can find any y. Just value रखते हैं n की निकाल देते हैं. No iterative solutions or anything, right? So you have solved this thing. Okay. If I ask you what is the transfer function of this system, can you tell me? Transfer function. पहले तो of course you have to recall from your summary notes or your practice what is a transfer function, right? Remember, this is what we call the transfer function, which is the Fourier transform of the impulse response, right? Frequency domain में ये होता है. ठीक, यहाँ से आप मुझे बता सकते हैं क्या होगा? Is there a way to find this thing? YZ, can you find HZ from here somehow? The steps you did, you don't need to come all the way here. Okay, how will you find it? The answer is already there in the steps you have done. क्योंकि मैंने erase कर दिए थे. I will write that quickly. If you remember, while solving this, firstly, of course, you will have to know that this is how the transfer function shows up. Yeah, this guy, HZ. Okay, so from there, do I know HZ? It's YZ over XZ, isn't it? Now, if you go back to when we were solving this problem, we had come to a point where we wrote YZ when we started out. We said, let's say, it was Z square over Z square minus 3 by 4 Z plus 1 by 8 times XZ. Remember this? जब start किया था ना आपने, first you had this thing times XZ, then we put XZ in here. right? But now from here, comparing to this thing, can you tell me what is hz?
So z squared divided by z squared.
Right? This says that yz is xz multiplied by hz. From here I can already see that yz is something multiplied by xz. That something has to be hz. So you have answered this question. मैंने erase किया हुआ था इसलिए I have to write it again, but you won't have to write it again. आपने पहले लिखा हुआ होगा, you will be able to extract it directly. So that part of the question is just free marks basically, if you know what an impulse, transfer function is. Now, follow-up question, last one, based on this. Is this system stable?
Yes, sir.
Okay, why?
Good question.
Good question. How do you check stability in frequency domain? Check the poles of the transfer function. Remember? हमने किया था ये last time भी. Check the poles of the transfer function. For discrete time systems, the poles have to be inside the unit circle. Okay. Now you don't have to do much. You have already factorized this in the previous step. So I will use that. Since you have already factorized this, I know that hz is basically z square over z minus half times z minus 1 by 4. Okay. What are the poles of this system? Poles are the zeros of the denominator, remember? So then what are the poles here? Half and 1 by 4. Yes. Now for a dt, so the poles, let's say let's call that z1, first pole, and second pole is 1 by 4. A discrete time LTI system is stable if the poles of its transfer function are where? Left half plane or inside the unit circle?
Inside.
Inside the unit circle. We have done this also. For Laplace transform, it's where is it? For continuous time, it has to be in the left half plane. Now these poles, are they inside the unit circle?
Yes.
They are less than 1. Yes. So this system is stable. Now this information should also be there somewhere in your summary note. What is that information? For a discrete time LTI system, stability means poles of hz are inside unit circle. Right? Now that statement alone will just give structure to your understanding, but practice will help you use that statement. Right? पर वो statement यहाँ होनी चाहिए आपके notes में, in your summary notes. Okay? So I think that's enough practice for today. So tomorrow we have quiz, Z transform. Right? Practice some more problems from the book also. If you have, let's